also going to, you should also know about like what is the differences between the OLTP and OLAP. So these are the two basic prerequisites in order to go ahead with the business objects. So first of all, if you have a certain knowledge about this, okay, you can easily understand the technical, okay, the technical things in the business objects. Okay, so first of all, let's go with a simple example. Like here is one scenario where in your organization, if you are working in an organization and your organization has been established, okay, in various geographical locations like in New York, California, Florida, or Dallas. Okay, so like this, you are having four different branches in four different geographical locations. So each geographical location has its own database. So whatever the data which is available would be stored in that particular, okay, heterogeneous databases in that geographical location. So whatever the data is, for example, see, your organization is a product based organization. Okay, so whatever the means like your database would be storing like, okay, what are the products have been sold, okay, for a particular year. So like this, like this, the data will be stored in each of these particular heterogeneous databases. So the database which is in the New York would be storing some sort of data, California would be storing some sort of data, Florida would be storing some sort of data, Dallas would be storing some sort of data. So like this, all the data would be maintained at different geographical locations, okay, with a different databases. Like whatever the database which is maintained in the New York, okay, could be like a SQL database. Whatever the database which is in California could be a Teradata. Whatever the database which is in Florida can be DB2. Whatever the database which is in the Dallas, okay, could be the could be Access database. So like this, we are having different databases established in different geographical locations which is having different operational systems. Okay, operational databases are available. Now as a sales manager, okay, I want to make a report which is consisting of, okay, which is consisting of the product based report, okay, which is having the sales of a particular product per year, per quarter, per city. Means I want to just check it out, okay, what is an sales of my particular product, okay, per a certain city for 2013 year for quarter 1. So like this, if I want to have some report to be generated, okay, at that particular time, the report generation with such kind of heterogeneous databases would be difficult. Okay, so what are the issues which would be coming up with these kind of databases is like, the first issue will be like this. Okay, so as I need to get the data from the various databases, so I need to establish a connection to the various databases which are remotely located. So there might be a issue in the there might be issue in the connection, okay, by which okay, there might be low performance. Okay, the issues will be like this, where you would be having the connectivity issues, it might be there, or the performance issues, it might be there. Why? Because you are connecting to the databases which are in the remote locations. Okay, so as you are connecting to the remote locations and you are trying to get the data from the various databases, there might be the performance issues or the connectivity issues which is going on, by which you cannot get the appropriate report what you're actually looking for. Okay, so this might be a issue. So in order to resolve this issue, okay, this is a common issue which goes on in every organization in day-to-day life. Okay, so in order to resolve this particular issue, okay, what we are going to do is, okay, we are going to extract, okay, the data which is in the different, okay, heterogeneous databases. I'm going to extract the data, and finally I want to put the data at one particular site. Okay, that's what we are doing. Means what according to my report requirement. Okay, according to the report requirement, whatever the data I require, as I'm looking into the sales report, so I want the sales information. So whatever the sales information which is stored in all these particular databases, I extract the only the sales information from them and put them into one particular common repository and store them at one site. This site is what called as a data warehouse. Okay, the data warehouse is nothing but, okay, it's a site where all the relevant data would be stored at one particular place. Okay, that is what called as data warehouse. The data warehouse also can be the database. Okay, the data warehouse is nothing but the database. It can be the SQL database, it can be the Teradata, it can be the Access database. So whatever may be the database, okay, it is storing the data which you get from the different heterogeneous databases into one particular site. Okay, that is what called as a data warehouse. Okay, so now once I put the data in the data warehouse, so what happens is I can generate the report very easily. Okay, how could I generate very easily? Means, see, instead of getting the data from the various databases, okay, there might be the connection issues. So now at this particular point, once the data warehouse is made, there is no connection issues. So obviously whatever the data is available in all these particular database would be coming into the data warehouse. So with that particular data which is in the data warehouse, I can generate the report very easily. So the end users also would be very much, uh, they also feel comfortable to get the data and to generate the reports very easily. Okay, why? Because there is no need of getting the data from various databases. Your data is almost available at the data warehouse. Okay, so that is a solution, okay, for the issue which we have come across in a organization. Okay, this issue would be there in almost all the organizations. So the best solution is like go for the data warehouse. Okay, so any doubts still here? You can just ping me in the chat box if you have any doubts. No, thank you. Okay, so now the next thing is like what are the importance of this particular database? The first thing is like the database would be storing the data, okay, in a meaningful way, in a consolidated way, okay, in well organized way, in a meaningful way it would be storing the data. Okay, so that that particular data can be used for the further analysis. Either it could be used for the reporting, either it could be used for the analysis, either it could be used for the data mining also. Okay, so such kind of cleansed data would be there in the data warehouse. Okay, so now let's go into the definition of this particular database. Okay, so this is a usage of the data warehouse. Like extract means whatever the data I put in the data warehouse, I won't get all the data from the databases. Means according to my requirement, I get the only that particular data would be bought from each and every database and put them at one particular place. Okay, that is what called as data warehouse. Yeah, tell me, Roy. Yeah, you can ask your question. Roy, you can ask your question. You can just type it there. Yeah, it's like historical data. You can see here warehouse consists of the historical data, whereas the databases would be consisting of the current data. That current data would be the historical data for the data warehouse. Okay, see, I have already written here. I'm just coming to that point. Okay, see, basically the data warehouse, okay, whatever the data which is consisting in the data warehouse, that could be in such a, that would be in such a way like it can be used for the analysis. The next one is like whatever the data is there, it would be refreshed in the regular intervals. Okay, it would be refreshed in the regular intervals, okay, up to date. Okay, further data analysis. Next one is like it would be consisting of the historical data, either the 6 months data, 12 months data, 8 months data, 1 year, 2 years, 6 years, 10 years data also would be there in this particular data warehouse. Okay, I'll tell you a simple example, okay, with this respect. For example, you have gone to a pizza house. Okay, I'm telling like how the data would be updated in the data warehouse. I'm just speaking about that particular by taking a scenario. You have gone to a pizza house. Okay, as you are going to pizza house, you would be ordering a pizza, or a simple example I'll tell you. No need for a pizza house. Let's go for the shopping. Okay, you go for a supermarket shop. Okay, and near the counter, okay, so the person would be generating the bill. Okay, so he is trying to enter the data into the databases. Okay, by reading the barcodes, he is just entering the data into the into his databases. At the same time, if the owner of that particular market want to see that see the report consisting of okay, today's sales. Okay, so at that time means both of them are simultaneous, means the person who is um, at the counter, he tries to insert the data. At the same time, the manager wants to retrieve the data in the form of a report. So at this particular situation, okay, the database is having much more effect. Why? Because okay, the person who is standing here is trying to enter the data and the other person is trying to extract the data. So as both the functions are simultaneously applicable on the database at that particular time, okay, so at that particular time, that particular situation could not be handled by the databases. Okay, in that situation, either the manager has to wait for some time, or the person who is making the bill has to wait for some time. Okay, so this is a situation what happens with the databases. Okay, why? Because their databases needs much time to get updated. Okay, and the synchronous calls cannot be answered properly by the databases. But this is not the situation with the data warehouse. Okay, so in the data warehouse, what happens is like once the data has been entered into the databases, the required information would be brought into data warehouse. So the person, the manager who wants a report can access this particular data warehouse rather than accessing the databases. So by which he can get his report requirement. Okay, so by which what happens is if the calls are synchronous also, okay, no person has to wait here. Okay, either the person who is at the counter or either the manager, no need to wait. Okay, they can make the call simultaneously. Okay, he can insert the data and he can extract the data simultaneously. Okay, so this is one of the example or one of the scenario where your data warehouse okay would be helpful. Okay, so it is helping us to maintain the data like a meaningful data, a consolidated data, a well organized data, and also the updates are regular. Okay, like whenever you put an update, either most of the updates would be at the nights. Okay, at the night the update would be done, and finally in the early morning the person can come and he can extract the data. Okay, so like this, it also consists of the historical data, which is like for many years also. Like databases would not be consisting of data more than 6 months, but the data warehouse would be consisting of your data for the many years also. Okay, so such kind of advantages are with the data warehouse. Okay, so now we are going to see like okay what is actually the data warehouse? A data warehouse is an subject-oriented, integrated, time variant, non-volatile collection of a data. Roy, you have asked me, okay, does it consist of a real time or the historical data? This is what. So it consists of the non-volatile collection of the data. Means it consists of all the data which is not volatile, which cannot be evaporated or which cannot be gone anywhere. For years it would be storing the data in the data warehouse. So in this, the subject oriented, okay, I'll just go through each and everything here. The subject oriented. So what do you mean by subject oriented here? Subject oriented means I already said you like the data warehouse would be consisting of the relevant data according to our requirement. For example, I want a sales data, so data warehouse will be consisting of a sales data, okay, or it consists of any product based data, so like that. Okay, the data warehouse would be consisting of a different data according to the report requirement or according to the user requirement, whatever the data actually the data where whatever the user needs, that data can be brought into the data warehouse, and that would be stored in a meaningful way. Means all the sales data at one place, all the material data at one place, all the the raw data at one particular place, all the master data at one place. So like this, okay, you can store the data in different sources. Okay, those particular things are called as a data sources. And the next one is like integrated in the sense, see, when you are getting a data, take this example here, okay, you are not getting a data from one particular database, you are getting a data from the various databases over here. Okay, that is what called as an integrated. Okay, so your data warehouse would be consisting of the data which you get from different data sources, not one particular database. It will be getting data from various data sources. So that's why we call it as an integrated. And next one is like time variant. Okay, what do you mean by time variant over here? It consists of the data for many years. Okay, like not the data for 1 year or 6 months. It consists of the data for many years. Data would be available in the data warehouse. So according to the time, you can extract the data. For example, in 2013 I want to go for the 2011 sales. Yes, the data would be available. I want to select 2005 sales data. Yes, the data would be available. I want to select 2001 data. Yes, the data is available. So like this, okay, according to the time, with the time variant, I can extract the data from the data warehouse. Okay, next one is it consists of a non-volatile collection of a data. What do you mean by non-volatile? The data will not go anywhere. Okay, it would be stored in the data warehouse for years together. Okay, so that is what the meaning of data warehouse is. A data warehouse is a subject-oriented, integrated, time-variant, non-volatile collection of a data. Okay. Now, you may be getting a doubt like, okay, how this particular, what is an architecture of this particular data warehouse, okay, and how the data would be stored in the data warehouse. Okay, so let's go and see in depth about the data warehouse architecture. So this is an data warehouse architecture. So I was telling you like, okay, I want to get the data from the various databases. Like here I am having 4 databases are available. That is operational system, ERP system, CRM system, and the flat files. Okay, so these are the 4 different databases which are available for us, or you can call them as a data sources which are available for us. Now, I want to extract the relevant data from these particular databases and put them into data warehouse. So here, which particular tool would be helping us to extract the data from these particular databases and put the data into the data warehouse in a meaningful way? So that particular tool is what called as an ETL tool. ETL is nothing but ETL, the full form of the ETL is extract, transform, and load. So whatever the relevant data you require, that particular data would be extracted, transformed, and loaded into the data warehouse in a meaningful way. So while loading the data into the data warehouse, there can be applied some sort of aggregations, there can be applied some sort of calculations can be applied, so there can be some sort of conditions can be applied. So all these things could be applied in the at this particular ETL part. So the ETL tool is a tool which would be extracting the data, transform the data and load the data into the data warehouse. So once the data comes into data warehouse, that could be used for the analysis, reporting and the mining purpose also. Okay, so this is the architecture of the data warehouse. So now, any questions still here? Guys, do you have any questions still here? Yeah, someone said yes. Yeah, go ahead, Roy. Of course, exactly. Good question. See, like your databases would be small, but not your data warehouse. Data warehouse is very huge. So as you said, like, okay, it can be some terabytes. Okay, so like your database would be like 100 GB or something like that, or MB something, but the data warehouse would be in the terabytes. Okay, so there is no problem for that particular. Okay, it could be like in the terabytes. The thing is very huge. Okay, what you call the data warehouse is very huge actually. Okay, yeah, it holds enough data. Why? Because I'm telling you, like, it can hold the data for years together. Okay, for years together, like 6 years, 10 years, okay, 20 years, like that. So obviously the data warehouse would be huge than when compared to the databases. Exactly. Okay, good question, by the way. Okay, so yeah, exactly. Bring all data or selective data. See, subject oriented in the sense I already said you, like, see, for example, I want the sales information. Okay, so only see here you can see like the data is stored in a like metadata at one place, raw data at one place, summary data at one place. Okay, so like that. Example, can it have the sales data along with the productivity data? Yeah, of course it can be. See, the thing is like what subject oriented in the sense that whatever the report requirement is there, it gets that kind of data and puts it into data warehouse. Like all the sales data would be at one particular place, all the product data would be at one particular place. So if you want like sales data means obviously there is an the products data would be available in that, the customer data at one place, material data at one place. So like this, okay, the data would be available at different locations. Okay, different locations. Okay, so these basic things are called as data sets or the data marts. Okay, these can be called as okay, which would be holding the relevant data. Okay, so now the next one is like, okay, here in the data warehouse, the data would be available in the form of the tables. So what are the tables here? There are two types of tables. The first one is the dimensional table. The second one is the fact table. Okay, so what are these particular dimensional tables? Dimensional tables would be consisting of all the primary keys to the fact tables and all the descriptive data. Descriptive data is nothing but the master data. The dimensional table would be consisting of all the master data. Take example of a customer details table. So all the customer details table is a dimensional data. Why? Because it can be consisting of like customer ID, customer name, okay, like and customer address, customer date of opening the account. So all these things would be in that particular table. So such kind of table which is descriptive or textual, okay, which will be giving us some master data, that is what called as a dimensional table. Those are called as dimensional tables. Each dimensional table would be having a primary key. Okay, primary key is nothing but a unique key in order to identify the data. Take an example of a student ID, customer account number, product ID, serial number. All these things would be the primary keys by which you can identify, like the things, like it gives a uniqueness. Okay, take an example of customer account number. Customer account number is unique, okay, rather than the customer name. Customer name can be the duplicate. Okay, there may be the duplicate entries, but the customer account number is unique. So that's why I call the customer account number as a primary key. Okay, so each and every table, each and every dimensional table would be having the primary keys. Okay, and the dimensional table would be consisting of the descriptive data, that is like master data. Okay, see, take an example of, okay, I'm having some bunch of tables over here. You can see here the time. Okay, so this is one kind of dimensional table. This is an item. This is one kind of dimensional table. The location, this is one kind of dimensional table. Okay, with the primary keys as item key, location key, okay, time key, branch key. Okay, these are all the primary keys, okay, which are related to the fact tables, okay. So these are all the dimensional tables. These are all the dimensional tables. Okay, if you could see, that would be giving us okay, the descriptive data, or the master data would be given by these particular dimensional tables. Next, the second one is a fact table. Okay, a fact table would be like which gives us the transactional data, okay, which gives us the information about the transactional data. And with this particular transactional data, I can apply the aggregations and the calculations. So such kind of a table is what called as a fact table. Okay, the fact table would be consisting of a foreign key to the dimensional table, and also it would be consisting of the numerical facts. It would be consisting of the numerical facts. Okay, so what are the numerical facts? Numerical facts are nothing but the key figures. These are the measures, okay, that could be calculated, aggregated. So such kind of things are called as numerical facts. Those would be in this table here. Okay, take an example of this: units sold, okay, dollars sold, average sales. All these are the measures. Okay, all these are the measurable values which could be measured, which can be aggregated or calculated. So such kind of measures would be maintained in the table called as a fact table. Okay, so there are basically, I'll just try to revise again. There are two types of tables. The first one is a dimensional table, which is consisting of the primary key to the fact table and the descriptive columns. Okay, so that would be telling us about the data, master data. So those type of tables are called as dimensional tables. The second one is a fact table. A fact table would be consisting of foreign keys, okay, to the dimensional tables, and it would be consisting of the measures also. Various measures would be there in the fact table. Like here, take an example of units sold, dollars sold, average sales. All these things are the measures. So these measures can be aggregated, calculated, okay, by using certain functions called as sum, count, minimum, maximum. Such kind of functions can be used on these particular columns over here. Okay, so this is what called as a fact table. Okay, so any doubts in these fact tables and the dimensional tables? Yeah, example of a store. So take an example of store. Store name, store location. Okay, store name, store location. Okay, next one is like the store timings. Okay, and store manager. Okay, and all these things will be coming under the dimensions. Okay, and coming to the store, the what you call like what store would be consisting of all of different products. all comes under the dimensions. Whereas coming to the fact, okay, coming to the fact, you can say like the revenue generated in that particular store, okay, and the number of products have been sold in that particular store. So all these would be coming under the facts, that is the measures. Okay, the quantity sold, the products quantity sold, okay, and the revenue generated. So all these would be coming under the measures. Okay, that is what the fact table. That is what called as a fact table. Means the fact table would be consisting of the columns which are the foreign keys for the dimensions and the various measures. The transactional data, day-to-day transactional data would be there in the fact table, like revenue generated per this hour, revenue generated per this particular what you call it day. All these things would be coming under the measures. Okay, number of products sold, okay, number of customers came to into the store. So all these things would be coming under the facts. Okay, whereas the entire store details, okay, which would be describing that particular store would be coming under the dimensional tables. Okay, so this is what called as a fact tables and the dimensional tables. Okay, Roy, did you understand? Okay, okay, fine. Okay, so here all these particular tables, okay, whatever the fact tables are there, dimensional tables are there. So these particular fact tables and the dimensional tables, okay, would be joined together, okay, following a certain architecture. Okay, this architecture is what called as a schema. This architecture is what called as a schema. There are three schemas available in our data warehouse. Means how these particular tables would be joined to the other tables, okay, that is set by these particular architectures here. That is, we are having the first one is star schema, next one is Snowflake schema, third one is fact constellation schema. These are the three schemas which are available. Mostly we are going with the star schema all the time. Okay, so how the star schema would be available? So how the star schema is made, that we are going to see in the next slide. So this is how the star schema is made. The fact table in the middle, surrounded by the various dimensional tables, okay, is what called as a star schema. Okay, the fact table surrounded by the various dimensional tables, okay, is what called as a star schema. Okay, so the star schema is nothing but it's just an architecture how the tables would be joined. See, after you get the tables into the from the data warehouse, so how to join these particular relevant tables? So you have to follow certain architecture. So here we are following certain architectures are there. Those are nothing but the schemas, and here we are looking into a star schema, which is a most important one. Okay, so what is a star schema? A star schema is nothing but a fact table surrounded by the various dimensional tables is what called as a star schema. Okay, so why do we go with the star schema all the time? Why? Because it has a simple structure, like only one layer, like fact table surrounded by the various dimensions, that's all. So it is very easy to understand. It's a simple structure, and the number of tables would be less, number of joins would be less. Okay, and also large this particular star schema is supported by the large number of business intelligence tools. So all the tools, okay, whatever we are using will be supporting mostly this particular star schema. So that's why we are going for the star schema. Whereas we are having something called as Snowflake schema. Snowflake schema is nothing but the fact table would be in the middle, surrounded by the dimensional tables, and each dimensional tables are again surrounded by few dimensional tables. Only one fact table would be there. one fact table. The Snowflake schema is like this. Fact table surrounded by the various dimensional tables, and each dimensional table is again surrounded or again joined to the other dimensional tables. This is what called as a Snowflake schema. Okay, it's called as Snowflake schema. Okay, got my point, everyone? Snowflake schema is nothing but fact table surrounded by the of course, only one fact table in both the schemas. Okay, yeah, the fact table surrounded by the dimensional tables, and these dimensional tables in turn surrounded by the various other dimensional tables or joined to other dimensional tables is what called as a Snowflake schema. Okay, next one is like a fact constellation schema. So what do you mean by fact constellation schema? Here in this particular schema I am using more than one particular fact table. Okay, the fact tables, either it may be like more than one fact table can be used here, surrounded by the various dimensional table, is called as a fact constellation schema. Okay, see here okay. Okay, so here into dimension to dimension means take an example of let's take it as a sales fact table over here. Okay, a simple example like sales fact table would be there. Okay, that would be surrounded by the the customer table. Okay, next one would be the the time table. Okay, and the next one would be here the sales is a fact table. Okay, next one here, one second, could be the product. Okay, so like this, and again these products are in turn connected to some other dimensional tables. Okay, some other dimensional tables, like for example these products okay can be like material. Okay, so material table again, and the next one would be like a salesperson. Okay, like who will be selling that particular products. Okay, so like this it would be connected in turn. In turn these products are connected to the material, and again these products are again connected to the salesperson. So like this what happens is a fact table surrounded by the various dimensional tables, and in turn they are surrounded by the various other dimensional tables. Okay, this is what called as a Snowflake schema. Roy, did you get this? So the product is there, the product is again connected to material, and the product is again connected to the salesperson as a dimensional table. So like this good question. See, for example, as I already said you, like good example. As I already said you, like see the each table okay should be having the primary key okay to the fact table. As these for example the material is there, the material is not directly related to the sales. Okay, so it is related to the products. Okay, and this is having a primary key which can be connected to the product only, not for the sales. Okay, so that's why most of the whatever the dimensional tables are there here. Okay, so the fact table must be in the middle, surrounded by the various dimensional tables which are directly linked to that particular sales. So there might not be all the time the tables okay which are directly linked to the fact table. So then at that time we are going to link or join them to the various other dimensional tables over here. Okay, No, no, we are not looking into the material, this thing, okay. I'm looking into the products sold, okay. So the product sold will be directly connected. The product sold will be like directly connected to the sales, whereas materials which are like the raw material, okay, like you can have the things like the different raw materials, okay, or like half finished or semi finished materials, so like this, so that would be joined to the products. Okay, so these do not consist of any particular measures. These would be consisting of only the dimensions only. No measures will be there in these particular tables. Okay, so this is how we are working with the Snowflake schemas. Okay, next, fact constellation schema is two fact tables. More than one fact table would be there surrounded by the various dimensional tables. Okay, that is called as a fact constellation schema. So after this particular schemas, okay, we are very much aware how we are maintaining the data in the data warehouse. Okay, and how the data would be available in the data warehouse. Okay, so I'll just have a quick review. So the data which would be getting from means whatever the relevant data is there, that relevant data would be bought from the various databases and put them into one particular place. That is what called as a data warehouse. So in the data warehouse also we'll be having tables. So these particular tables are linked up or joined up together by following certain schemas over here. Okay, so by which what happen is I can generate the I can analyze these particular data very easily. I can generate the reports very easily, okay, by using the data which is in the data warehouse rather than the data which is available in the the operational databases. Okay, so this is all about the data warehousing. So any doubts in this, you could just ask me. Anushka, Matthew, Roy, any doubts in these things, you can just ask me. Like, why? Because we are just continuing with the, after this one we are going into what is an ETL tool and what is a business, actual business objects, we are going into that. Okay, so that's why if you have any doubts in all these data warehousing concepts, you can just ask me. Yeah. So now I'm just concentrating on the ETL part now. Why? Because as I'm a business intelligence guy, okay, so obviously, okay, I don't want to go ahead with the data warehousing concepts and all these things. Okay, I just want to be, you know, a step ahead with the business intelligence. So first of all, let's go to then the architecture of the data warehouse over here, where you are using an ETL tool. The ETL tool here, okay, would be extracting the data, transform the data, and load the relevant data into the data warehouse that could be used for the reporting, for the analysis, and for the data mining purpose. Okay, so this ETL tool, okay, could be anything. Okay, there are many ETL tools over here. The job of the ETL tool is to extract, transform, and load the data from any number of databases into one particular data warehouse. Okay, that is what called as an ETL tool. Okay, so it reads the data from various databases, okay, and transforms the data according to our requirement by applying certain okay, transformations like calculations, aggregations, certain transformation rules can be applied on that particular data to get the data uh, which would be very easy for us to understand. So such kind of data would be transformed, and that is loaded into the target databases. Target databases here is the data warehouse. So I extract the data from various databases, transform the data by applying certain rules on that particular data, and transform that particular data in such a way like I can understand very easily and load it into the target databases or the data warehouse. This is what called as the ETL tool. The function of the ETL tool is that. Okay, and here are the few ETL tools which we have in the market. So like a business objects data integrator, okay, informatica power center, okay, and coming to the SAP, okay, it's like a business intelligence is a ETL tool which can be used. Okay, so like this we are having many ETL tools which are available in the market. Okay, so next comes the what is the business object.